On June 21, 1948, something extraordinary happened almost quietly in a Manchester lab. It didn't look like much, a jumble of wires, a cathode ray tube, and a glimmering screen. But the Manchester Baby, or small-scale experimental machine, was about to change everything. Developed by Frederick Williams, Tom Kilburn, and Jeff Tootill, this machine ran a simple 17-instruction program. That might sound tiny now, but it was the first time a computer ever stored and executed instructions electronically, no rewiring, no punch cards. This was the moment the world glimpsed the future of computing. Now, Alan Turing didn't build the baby, but his groundbreaking ideas were right there in the room. Turing's universal machine theory inspired the way computers could solve any problem if only they had the right program. At the same time, Turing was already working on the baby's big sibling, the Manchester Mark I. What made the baby truly revolutionary was its stored program architecture. We call it von Neumann architecture today. Instructions and data living side by side in memory, making the computer flexible and programmable. It's memory that came from the Williams-Kilburn tube, an early form of RAM storing just 32 words of 32 bits each. Humble beginnings, but absolutely groundbreaking. From this small breakthrough, bigger things followed. The baby led directly to the Manchester Mark I, and soon after the Ferranti Mark, won the world's first general-purpose, commercially available computer. This was the spark that set off the move from hardwired, single-purpose machines to the programmable systems we rely on today. Every digital device in your life, your phone, your laptop, even the systems that run electric cars and spacecraft, owes its existence to what happened in Manchester that day. The baby's flickering screen was the heartbeat of a new era, launching the digital age and shaping society in ways no one could have predicted. So next time you tap a screen or ask an AI a question, remember it all started with one quiet, world-changing moment in 1948.
On June 21, 1948, the world witnessed a quiet yet transformative moment in a lab at the University of Manchester when the Manchester Baby, officially known as the Small-Scale Experimental Machine, SSEM, became the first computer to successfully run a stored program. Developed by Frederick C. Williams, Tom Kilburn, and Jeff Tootill, the baby executed a 17-instruction program that demonstrated for the first time that a computer could store and run instructions electronically, without rewiring the machine, a concept that marked the birth of modern computing. Though Alan Turing didn't build the baby, his theoretical work on the universal machine profoundly influenced it. Turing was at Manchester at the time, working on the baby's successor, the Manchester Mark I. The baby's key innovation was its use of stored program architecture, now known as the von Neumann architecture, in which data and instructions reside in the same memory. Its memory was built using the Williams-Kilburn tube, an early form of RAM that stored 32 words of 32 bits each on a cathode ray tube. Although modest in technical power, the baby became the prototype for more advanced systems, including the Manchester Mark I and the Ferranti Mark I, the world's first commercially available general-purpose computer. This development helped spark a global shift from hardwired, task-specific machines to programmable systems, enabling the rise of software development,